Hello and welcome to my YouTube channel. In this video we will be discussing about numericals related to basic soil properties. Already we have discussed two types of numericals, that is in part 1 and part 2. The part 1 was based on simple soil properties and part 2 was based on interrelationship between soil properties. Now in part 3 we will discuss the problems involving combination of basic soil property formulas and soil interrelationship. So in part 3 or type 3 numericals, we will discuss about the numericals in which both the properties of soil will be required, that is basic soil formulas and soil interrelationship to solve a problem. So suppose we have a soil sample has a total volume of 5 centimeter cube and the volume of void is 2 centimeter cube. The weight of soil or the specific gravity of soil is given. Suppose specific gravity of soil is known to you. Specific gravity of soil is 2.65. If the soil is saturated, then find the bulk density of soil. How we will solve such problems? So we can write the given data given data is total volume of soil is 5 centimeter cube, volume of void is 2 centimeter cube, specific gravity of soil is 2.65, and we need to know the bulk density of soil, and it is also given that the soil is saturated. So if we go by the bulk density formula, one formula for bulk density is total weight upon total volume. Another way to find the bulk density is to use the soil interrelationship, that is G plus SR into E upon 1 plus E into gamma W. These two formula, this is from interrelationship and this is from basic soil formula, but none of them can be used to find the bulk density of soil, as we don't know the total weight. There is no term of weight here, and in this case we don't know the void ratio. So first of all we will have to find the void ratio, and then only we can find the bulk density. We don't have water content or anything that we could use directly the relationship, that is SR into E is equal to W into G. We could have used this relationship to know void ratio, but we can't use this relationship because we don't know the water content. So what we need to do is, first we will return to the basic soil formulas, where This formula we can't use because we don't have weight, so we will have to use this formula. And finally here one unknown is there, that is void ratio. So we can say the basic formula for void ratio is volume of void upon volume of solid. So we have total volume and volume of void. So total volume we can say, so we know the volume of void, volume of solid is unknown in this formula. How we can calculate that? That we know that total volume is equal to volume of void plus volume of solid. So we can write total volume, that is 5, is equal to volume of void, that is 2, plus volume of solid. So we get volume of solid as 3 centimeter cube. Now from this we have got volume of solid, and volume of void we already know as 2 centimeter cube. So we can write void ratio will be 2 by 3. So we have found out the void ratio, and now we can use this formula directly, as we have been given that the soil is saturated. So we can write SR will be equal to 1. So now we can use that formula. We have already found the void ratio. From basic soil formulas we have found the void ratio, that is after calculation E is equal to 2 by 3. So we can put it here. We can write that bulk density will be equal to G is 2.65 plus degree of saturation is 1 into E, that is 2 by 3, upon 1 plus 2 by 3 into gamma W. If you want to find the unit weight in kilonewton per meter cube, we will use 10 kilonewton per meter cube, unit weight of water. If we want to find the bulk density in gram per centimeter cube, then we will use gamma W as 1 gram per centimeter cube. So we have two values, gamma W is equal to 1 gram per centimeter cube and gamma W is equal to 10 kilonewton per meter cube. Depending upon the unit in which we want to calculate the bulk density, we can use this formula. So we can write this as 2 by 3 is around 0.67. If we are using here 10, then we can write it as 2.65 plus 0.67 upon 1 plus 0.67 is 1.67 into 10. So it will be around 2.65 plus 0.67, that will be 3.2, around 3.2, and into 10, that is 32 upon 1.67. We can simplify this and we can get the bulk density in kilonewton per meter cube. Thank you for watching our video. Please subscribe to our channel. Link for more numericals related such numericals, link for the book, reference book has been provided in the description. You can visit that link. Further, to like our videos, further to watch other part of these videos, you can visit our channel. Link for other parts of numerical have also been provided in the description.